Hello everyone, welcome to this video on how to use TI-84 calculator and introductory statistics class. In this video, we are going to learn how to perform hypothesis testing with two samples using TI-84 calculator. Let's begin with an example. First, we are going to look at z-test for difference of two means. Here is the question. A professor at university wants to see whether there is a significant difference in the age of resident students and commuting students. He selects a random sample of 50 students from each group. The average age of the resident students is 22.12 years and the average age of commuter students is 22.56 years. At alpha equal to 0.05, decide if there is enough evidence to reject the claim of no difference in the age of two groups. Assume the population standard deviation sigma 1 equal to 3.68 and population standard deviation sigma 2 equal to 4.7. So we want to reject the claim. We want to see whether there is enough evidence to reject the claim, and the claim is reject the claim of no difference in the age of two groups. So the claim is there is no difference in the age of two groups. There is no difference in the age of two groups. That is what we are testing here. So we can write the null and the alternate hypothesis first. Our claim is, look at this one, our claim is of no difference in age. So when I say mu1 is equal to mu2, then there is no difference in the age. That is the same age. No difference, it is the same. No difference means same. So this is your claim. This is the claim. And because there is equal to sign, that is the null hypothesis. So the alternative hypothesis will be H sub A is mu1 is not equal to mu2 will be the alternative hypothesis. So first step is to find the claim, and using that claim, we have to state the null and alternative hypothesis. Now what we need to do is, using our calculator, we have to find the p-value and compare with alpha. Here, in order to find the p-value, you have to go to stat, test, and select the appropriate test in TI-84 calculator. Because the population standard deviations are given, it is the z-test for two means. And then once we go to the appropriate test window, we have to input the information given here in the problem and then find the p-value. Now I'm going to demonstrate that using TI-84 calculator. Here is my TI-84 calculator. We go to stat, and then we go to test, which is here. After we go to test, we select the appropriate test. In this case, it is the two sample z-test, which is number 3. Two sample z-test. And in the problem, the data is not given. Instead, the stat is given, or the information is given. So we select that in the first line. Second, we have to input the value. So sigma 1, it is 3.68, 3.68. Then we need sigma 2, which is 4.7, 4.7. Next, we need the mean of first sample. Mean of first sample is 22.12, 22.12. Mean of this first sample is 22.12. Now here we need the first sample size N1. First sample size is 50. Next, we need the mean of second sample, which is 22.56, 22.56. And then we need the size of the second sample. Second sample size is 50 because the sample size is same. And in the alternative hypothesis, we have not equal to sign, which is good. Color, you can select any, and then you can calculate or you can draw. It is up to you what you want to do. Let me draw this. So by drawing this, I got the p-value, and p is 0.6022. So we obtain the value of p from TI-84 calculator. It is p equal to 0.6022. After you get the value of p, we compare the p with alpha. So p is 0.6022, alpha is 0.05. So here p is greater than alpha. So here p is greater than alpha. So if p is greater than alpha, we fail to reject null. So we say we fail to reject null hypothesis. We fail to reject the null hypothesis. Meaning of that is we cannot reject the null. We fail to reject. So we are not rejecting the null. That means we are going with the claim and we are rejecting the alternative hypothesis. So the claim was there is no difference in the age of two groups. So your conclusion will be there is, so is there enough evidence to reject the claim? We are not rejecting the claim. So there is not enough evidence to reject the claim at alpha equal to 0.05. So that will be our conclusion, and we'll write that. There is no enough evidence to reject the claim at alpha equal to 0.05. So this is how we can use TI-84 calculator to test the hypothesis using z-test for difference of two means. Now we are going to look at t-test for difference of two means. Here is an example. A random sample of teachers from two different schools are collected to study their average salary. The table below summarizes their statistic. Is there a significant difference in teacher salary between two schools at 5% significance level? So is there a significance difference? So we are looking at the difference. Is there a significance difference in teacher salary? We are not looking at the same. Instead, we are looking at the difference. Okay, so that is the claim. You can see, is there a significant difference in teacher salary between two schools at 5% significance level? So meaning of this 5% significance level is alpha equal to 0.05. So in order to test that claim, the data is collected. For the first school, the sample size is 15, average salary is 35,270. Standard deviation of the first sample is 3,256. Similarly, for school B, the sample size is 30, average salary is 29,512, and the standard deviation of the second sample is 1,432. So here we are using the population standard deviation is not given. Instead, the sample standard deviations is given. That means we are using the t-test for difference of two means. First, we need to state the null and the alternative hypothesis by identifying the claim. And in the claim, we are checking, is there a significant difference in teacher salary? So if I write the average salary like this, mu1, if I say mu1 is not equal to mu2, I'm saying that the salaries are not the same. Not the same means there is a difference, and that is our claim. That is our claim. And in this claim, there is not equal to sign. So this must be the alternative hypothesis. So your null hypothesis is the opposite of that. It will be mu1 equal to mu2. So once we have the null and the alternative hypothesis, we have to find the p-value and compare with alpha. In order to find the p-value in TI-84 calculator, we go to stat and then test, and we select the appropriate test. In this case, the appropriate test will be, since the sample standard deviations are given, it will be the t-test for the difference of two means. We input all the information, enter the information in appropriate test window, select it and hit calculate to get the p-value. So after we enter the values in TI-84 calculator under the selected window, we'll calculate the p-value. So let me show you how we can use our TI-84 calculator to get that p-value. Here's my TI-84 calculator. We go to stat and then test. In this case, we are looking at two sample t-test. We have two samples and we are looking at the t-test, which is number 4. So we hit number 4. Then we go here. The stat about the set is given, or the samples is given. So we'll select that. Now the first mean of the first sample is 35,270. So we do that, 35,270. That is the mean of the first sample. Standard deviation of the first sample is 3,256. 3,256. First sample size is 15. Similarly, mean of the second sample is 29,512. 29,512. Standard deviation of the second sample is 1,432. 1,432. Size of the second sample is 30. In the alternative hypothesis, we have not equal to sign, which is good. They will ask for pulled or no. You can just say no. And then color, it's up to you what color you want to select. And here you can either hit calculate or draw. I'm going to draw and then hit enter. So there is the drawing. And we have the p-value, which is approximately 0, a very, very small p-value. If you increase the number of decimals, I have fixed it to 4 decimal places. If you increase the number of decimals, then you should get 0.000014. So p equal to, change the number of decimals, you will see 0.000014. 0014. In this case, I have 1, 2, 3, 4, 5, 6 decimal places. So from the calculator, when we change the number of decimals, p is very small, 0.000014. That's the value of p. Now in next step, we are going to compare the value of p with alpha. P is very small value, whereas alpha is 0.05, meaning of that is p is smaller than alpha. So in next step, p is smaller than alpha. So we know that when p is smaller than alpha, we reject the null hypothesis. So you can say we reject the null hypothesis. So null hypothesis gets rejected. So this is rejected. So we are going with the alternate hypothesis, or we are going with the claim. So meaning of that is the conclusion will be there is enough evidence to support the claim at 5% significance label. So there is enough evidence to support the claim at alpha equal to 0.05, which is same as 5% significance level. So this is how we can use our TI-84 calculator to perform the hypothesis test involving two samples using the t-test for the difference of two means. One more type of hypothesis testing using TI-84 calculator. This one is z-test for proportions. And here we have the quick question. A survey of 60 students at CCA found that 36 own house. So 60 students at CCA, 36 own house, and another survey of 50 students at CCD, 28 own a house. At alpha equal to 0.05, is there a difference in proportion? Is there a difference? So we are checking whether there is a difference or not. When I say the difference, what I'm saying is this. P1 is not equal to P2, meaning of that is I'm saying that this is not the same. That means there is a difference. So this is my claim. This is my claim. And because there is not equal to sign, this is the alternative hypothesis. The null hypothesis will be opposite of that. And we say P1 is equal to P2. And in order to test this claim, the two samples are taken. The first one is 60 students at CCA, 36 own a house. So 60 is N1 and then 36 is X1. Out of 60, 36 own a house. Similarly, 50 students at CCD, 28 own a house. Meaning of that is 50 is N2, second sample size. Out of 50, 28 own a house, so 28 is X2. Alpha is 0.05. We have to check whether there is a significance difference or not, whether we can support this claim or we can reject the claim. So what you have to do is, in order to check whether this claim is true or not, we have to find the p-value and compare with alpha. In order to find the p-value, we go to stat, test, and we select appropriate test. When I say appropriate test here it is talking about the proportion. Whenever we are talking about proportion and there are two samples, we use the z-test for two proportion. We enter the information in this appropriate window and we get the value of P. So let me show you how we can do that in TI-84 calculator. Okay, here is my TI-84 calculator. Now we go to stat and then we go to test, which is here. And then we select the appropriate test. In this case, it is 2 proportion Z test, which is number 6. Then we are going to plug in the information. The first one is X1, which is 36. And then the sample size, it is 36 out of 50. So the first sample size is 50. Similarly, X2 is 28. And it is out of 50. Here, the first sample size is 60. I entered the wrong information. Let me correct that. That is 60, 28 out of 50. In alternative hypothesis, we have not equal to sign, which is good. Now down here, you can either calculate or draw, whichever you want, you can do it. You'll be able to find the value of P. Let me draw this. So if I hit draw, you'll see the drawing and also you'll see the P value. Your P is 0.6719. So from calculator, we got the value of P. P is equal to 0.6719. Now what we are going to do is we are going to compare this P value with alpha. So P is 0.6719, which is greater than alpha. So here we got P bigger than alpha, more than alpha. And we know that when P is more than alpha, we reject the null hypothesis. So let me write that here. We reject the null hypothesis. So I can cross out the null hypothesis because I'm rejecting it. Okay, P is greater than alpha. So hold on. P is greater than alpha. So we don't reject the null hypothesis. We fail to reject the null hypothesis. Excuse me there. We fail to reject the null. Let me write that. Fail to reject the null hypothesis. So I am not rejecting the null. I'm instead rejecting the second one. That is, I'm rejecting the claim. I'm supporting that. So I am not able to support the claim. Meaning of that is, there is not enough evidence to support the claim at 5% significance label. So there is not enough evidence to support the claim at alpha equal to 0.05 or 5% significance label. So this is how we can use TI-84 calculator to perform the Z-test for two proportion. This is the end of this video. I hope you find it helpful. Thank you so much for watching.